let's begin. So x squared plus x minus 12, well-known culprit to factorize. We just have x plus 4 and x minus 3, which simplifies to x being equal to negative 4 or x being equal to 3. Just follow the zero product rule. Okay, 1.1.2 means we need some cleaning up. Now that's done. Let's just have here square root of 2x plus 1 being equal to x minus 1. Well, that's already in a very nice state as is, so we can just square both sides because it's ready for that. So over here we have what we want. We have gotten rid of the radical sign, so we'll have 2x plus 1, and on the right hand side we have x squared minus 2x plus 1. Of course, what we want to do is transpose all values to the right where the x squared is. Okay, so that happens over there, minus 2x, and of course we have minus 1. So what do we have? 0 being equal to x squared minus 4x, and then, well, we subtracted 1 over here, not that squiggly line, so that just zeroes out completely. So let's just follow what we have, x and x minus 4 all equal to 0, therefore x is equal to 0 or x is equal to 4. Customary to test. Well, we can test on top. Well, 2 times 0, if we test the value 0, is 0 plus 1, it's 1. Okay, so square root of 1 is just 1, and then 0 minus 1 is just minus 1. So 0 is invalid in this case. How sad for 0. And then for the value 4, 2 times 4, if we test the value 4, 2 times 4 gives us 8 plus 1 is 9, square root of 9 is 3, and over here 4 minus 1 quite simply equates to 3 as well, and 3 is equal to 3, so that does it for us. It's a good value, it's not naughty. Radio moving right along. Well, over here we have something that's trying to scare us because it has a radical sign inside the exponent. But fear not, for we have the tools, we have the technology. So that reads 2 to the power x times the square root of x is equal to 2 to the power 27. Yes, I read that right. 2 to the power 27. Well, there's nothing scary about that. Let's just deal with this. So that's x to the power 1. Now, and then this. So let's just write this square root of x. That's going to be x multiplied by x to the power 1 over 2. And 1 plus 1 over 2 is 3 over 2. So we'll have 2 to the power, well, x to the power 3 over 2, which is equal to 2 to the power 27. So we'll follow our exponential laws. We have a base that's the same, and we have two exponents that make a bit more sense. Well, so that drops down and that drops down, and we'll have x to the power 3 over 2 being equal to, well, that's just 3 to the power 3. So what do we do with this now? Well, we raise it to a specific power, the reciprocal of 3 over 2, which is 2 over 3. Because what that does is it allows that exponent to become 1. But what we do on the left, of course, we do on the right. And the same thing occurs over there, which means x is equal to 3 to the power 2, and x is of course equal to 9. Right, so No demons when we keep our head about ourselves. None whatsoever. And then finally for this set, let's just get a pen back, please. We need a pen to write with. Bluish is cool. As is customary, there should be a quadratic inequality in the mix. And there it is. Well, we know what to do with this by now. That's x minus 4, x plus 2 being the factors, still less than 0, of course. Then we need our critical values for CVs. It should be x equal to 4 or maybe and x is equal to negative 2, because both are critical, not just one. We need both. We need both critical values because they need to form part of the tool we use to actually solve this inequality. And the other critical value on the right hand side, the biggest one obviously, is 4. So let's have a look what we want. Well, this says less than, that's at the bottom, which means we're looking at this connected area over here, which should reflect in our inequality. So x is greater than negative 2 and less than 4. And that is good. That works.